So we have completed the different types, the conductivities of different solids and how the properties, this property, conductivity of solids differ for different types, that is the conductors, semiconductors and insulators. Then we studied how the conductivity of semiconductors can be increased. It can be increased either by heating, and such type of semiconductors are called intrinsic semiconductors, and the conductivity can also be increased by adding impurities, and the process is called doping. We can add either an electron rich impurity and then we get an n-type semiconductor, and if you are doping with an electron deficient impurity, that is group 13 elements, we will get an p-type semiconductor. That we have already completed, and I told you the application of n and p semiconductors. We can prepare many semiconductor devices using this type of semiconductors. That is, we can either couple n and p, p and n, and then we can sandwich one semiconductor between the other two, that is NPN or PNP. Like that we can sandwich them, and we can use them for amplifying radio signals, etc. So transistors, amplifiers, etc. can be made using such semiconductors. Now we are going to magnetic properties. Now before that, there are certain other type of compounds called 12-16 compounds and 13-15 compounds. See, there are 12-16 compounds or 13-15 compounds. Now what are these? See, the germanium, silicon, etc. as chosen as semiconductor bases because they have a valency of 4. So if we can prepare a combination of two elements whose valency, the average valency is 4, we can use that combination as a semiconductor base. For the 12-16 compounds, 12 compounds are zinc, cadmium and mercury. Group 16 compounds are oxygen, sulfur, selenium, tellurium, etc. If we compare group 12 compounds, their valency is 2. Group 16 it is 6. The average valency is 2 plus 6 by 2, that is equal to 4. So the average valency is 4. So we can use the combination of such elements, that is group 2, group 10 and group 16 elements. We can use them as a semiconductor base. For example, zinc oxide, cadmium sulfide, mercuric selenide, mercuric telluride, etc. That is ZnO, then HgSc, HgTe, etc. we can use as the semiconductor bases because their average valency is 4. Then group 13-15 compounds. Now what are which are 13th group elements? Boron, aluminium, gallium, indium, thallium. And 15 compounds are nitrogen, phosphorus, arsenic, antimony and bismuth. Arsenic, antimony and bismuth. These also can be, the combination of these two elements also can be used as a semiconductor device because their average valency is 4. So this is 13-15 compounds and 12-16 compounds. Now certain oxides of certain metals like titanium, etc. they act like metals in their conductivity. We can prepare those oxides also as metals. We can behave them as metals in conductivity. Now we come to magnetic behavior. So these are the compounds and their conductivity, etc. We will come back to another property, that is magnetic properties. Magnetic properties. In magnetic properties also, solids differ in many ways. First thing is, how do these elements and substances get magnetic property? See, the electrons. we know that electrons are rotating around the nucleus. Nucleus is positively charged and electrons are negatively charged. When they are rotating, the electrons are spinning on its own axis. They are spinning on their own axis. So therefore, when they are moving or they are cutting the field, so they acquire certain magnetic momentum, and this magnetic momentum will change if the spin is in opposite direction. For one, we know that in an orbital, one electron spin in clockwise direction and the other spin in anti-clockwise direction. So if one spin in clockwise direction, the magnetic moment will be in one direction, and if it is spinning in the opposite direction, it will be having in opposite direction. And if they are paired, electrons are paired, they may cancel each other. But if they are unpaired, they may not cancel. And this magnetic moment is measured in terms of unit called the Bohr magneton. BM. It is Bohr magneton. Now, this suppose an atom or a compound or a molecule is having unpaired electron. If the unpaired electrons are there, then this magnetic moment due to the spin, it is not cancelled. Then that substances which are having an unpaired electron in their molecule, they are weakly attracted in a magnetic field, and such substances are called paramagnetic substances. Paramagnetic substances. So paramagnetic substances are those substances which have unpaired electrons in their molecule. Understood? If unpaired electrons are there, the magnetic moment is not cancelled. So such substances, their molecules will be weakly attracted in a magnetic field. So there they are called paramagnetic substances. Now if all the electrons are paired in a molecule, then that means they will be repelled in a magnetic field, and such substances are called diamagnetic substances. Diamagnetic substances. So in 11th class we have studied oxygen molecule is paramagnetic in nature because oxygen molecule is having an unpaired electron in its, two unpaired electrons in its antibonding molecular orbital. So it's like that. Here paramagnetic substances are those substances whose molecule contain unpaired electron, and the diamagnetic substances are those which have all paired electron. Now in solids, the molecules, group of atoms which are having certain magnetic moments, they are grouped together and they are called the metal ions. They are grouped together, and this small groups, they are called the magnetic domains. These magnetic domains also have particular direction. They will be arranged, but at random they will be arranged in a substance. When a strong magnet is shown to this such type of substances, if all the domains are arranged in a single direction, if all the magnetic domains are arranged in a single direction, then such substances will be strongly attracted in a magnetic field. Like this, if all the domains are arranged in the same direction, these magnetic domains are formed by small groups of metal ions, which are small groups of metal ions are called the magnetic domains. If these magnetic domains are arranged in the same direction, and if such substances are kept in a magnetic field, they will be strongly attracted in a magnetic field, and when the magnetic field is removed, then they retain their magnetism. ഇങ്ങനെയുള്ള substances, that is when all the domains are arranged in the same direction, അങ്ങനെയുള്ള substances ഒരു magnetic fieldൽ വെച്ച് കഴിഞ്ഞാൽ what happens is, അല്ലെങ്കിൽ ചിലപ്പോൾ ഡൊമൈൻസിന്റെ ഡയറക്ഷൻ വേറെ ആയിരിക്കും, പക്ഷെ മാഗ്നറ്റിക് ഫീൽഡിലേക്ക് വെക്കുമ്പോൾ ഈ ഡൊമൈൻസ് എല്ലാം ഒരേ ഡയറക്ഷനിൽ അറേഞ്ച് ചെയ്യും. അങ്ങനെയുള്ള സബ്സ്റ്റൻസ് എന്ത് ചെയ്യും? they will be strongly attracted in a magnetic field, and even after removal of the magnetic field അങ്ങ് മാറ്റിയാലും what will happen? they will retain their magnetism. ഇപ്പൊ നമുക്കറിയാം, ഇരുമ്പ് കഷ്ണത്തിൽ നമ്മൾ എന്ത് ചെയ്യുന്നു, ഒരു മാഗ്നറ്റ് കാണിച്ചു കഴിഞ്ഞിട്ട് പിന്നെ ആ ഇരുമ്പ് കഷ്ണത്തിലേക്ക് നമുക്ക് പിന്നെ അറ്റാച്ച് ചെയ്ത് വെക്കാൻ പറ്റും അല്ലേ? because this is that metal piece is now a magnet, because in that the magnetic domains are arranged in a same direction. അതുകൊണ്ട് അതെന്താണ് ഒരു മാഗ്നറ്റിക് എഫക്റ്റ് കിട്ടും. പിന്നെ അതിലേക്ക് നമുക്ക് ഇങ്ങനെ ബാക്കി അയൺ പീസസ് ഒക്കെ അട്രാക്ട് ചെയ്യും. Such substances are called ferromagnetic substances. Ferromagnetic substances. So ferromagnetic substances are those whose magnetic domains are arranged in all in same direction when a strong magnetic field is applied. For example, Fe2O3. Now, there are certain other substances whose magnetic domains are arranged in such a way that the net magnetic moment is zero. That is, the same number of magnetic domains are arranged in the opposite direction. For example, like this. Like this. If all the magnetic domains are arranged in the different opposite directions so that they cancel each other, then such substances are called antiferromagnetic substances. Antiferromagnetic substances. So ferromagnetic substances are those whose magnetic domains are arranged in the same direction so that they are strongly attracted in a magnetic field and they retain their magnetic moment. Now, antiferromagnetic substances are those whose magnetic domains arranged in different direction so that they cancel each other and they are not attracted in a magnetic field. They are called antiferromagnetic substances. Now, in certain substances, the number of domains arranged in the opposite direction will be in different number, so that there is a net magnetic field or magnetic effect. See, like this. If they are arranged in the same direction, in opposite ways, like this. Now they are in different numbers, so that means there will be a net magnetic field for them. So such substances are called ferrimagnetic substances. Ferrimagnetic substances. So ferromagnetic, antiferromagnetic and ferrimagnetic substances are there. Then we have paramagnetic substances and diamagnetic substances. So these are the magnetic properties of solids. Now we have finished that chapter. Now what can we do is, you do exercises in a separate book. Then I will give the other questions, remaining questions, and you will have to answer them. Okay.